fingerprint recognition if you have chase. Then finally the integration of these three frameworks increase the accuracy of the cognitive system. The voice recognition is is an algorithmic framework dedicated to speak embedding extractions embedded in the speaker. It has four components: front end, encoder, police, and projector. The front end is extract frame embedding, can be either DNA, SSL feature, post feature, and encoder. Model frame embedding can be either of CNN, RNN, transformer, and fully aggregate into an atlas embedding can be either mean, attentive, statics, and in the projector, further process the neutrals embedding consists of one or more among two connected by normalization. This one is the facial recognition ghost-based framework, leveraging advanced computer vision technique, which is used for face recognition. Unlike the conventional neural network algorithm, the algorithm comprises two main components: feature extractor and classifier. The fingerprint recognition FPGA higher secure and accurate personal identification. Following processing the FPGA algorithm goes to segment the image into patches. First, it's segmented. If we give 4 of our finger, it's a segment identifier. Separate each finger images. So, how to integrate the result of these three frameworks. The first one is just voting to take the highest one, and the second is averaging from each modality. Instead of taking the highest value, taking the average. The best one is weighting the each strategy, then take the average of the weighting averaging data. This is the integrated strategy. You train each framework and assign a weight. Each modality undergo independent training and testing to assess its performance. Appropriate weights are assigned to each modality based on their performance. As I said in the background, each modality has its own accuracy and performance. So during the integration phase, the sample to verify are input into the model of each modality. The prediction results from each modality are weighted and averaged based on the predetermined weight accepted. The research methodology used in the study designed to integrate various modalities to create a comprehensive authentication solution, and the quality method of research of design, data collection through survey, and machine learning setting for data analysis. The finding in the data collection, the finding of the literature review conduct to gather existing knowledge and research on the topic, evaluate the user experience and acceptance of multimodal system, to evaluate and optimize environmental security through the integration of multimodal system. And the finding user acceptance, experience and acceptance. Overall experience satisfied is 5%. Ease of use is 75%. User interface design is 5%. Challenge faced is 50%. Sometimes it's not easy to use. When you start to scan your fingerprint, if you have some weight or dust in your hand, it's not easy access. Or to also to take face recognition with the camera, interact with some light, like that. Robustness data protection measure 65 acknowledge significance of encryption protocol, 72% recognize the importance of secure, safe, and 4% emphasize the significant terms of transmission protocol. Implication of multimodal biometric security is two-person participant in identifying access control, e-government learning, and national ID. Now, in the word national IDs, in the highest percentage this biometric system. And the contribution multimodal biometric integration, integrate multimodal systems such as voice, facial, and fingerprint recognition to study demonstrates the potential of enhanced security and user authentication. User-centric design approach by focusing on user experience, classification, and acceptance. The study introduced novel strategies for improving the usability and effectiveness of biometric authentication technology. Machine learning application by leveraging machine learning algorithms, the research provides insight into user perception, data protection measure, and system performance. In conclusion, effectiveness of multimodal biometrics integration. The integration of multimodal biometrics can significantly enhance security measures across various domains. User experience and acceptance, user-centric design approach play a crucial role in fostering positive user acceptance, perception and acceptance. Robustness of data protection measure, finished, maybe 1 minute. The importance of ongoing communication and transparency data protection measure. Implication for security measure. It's also enhance the security measure. In the limitation, because of the specific demographic data participants are, so it needs a little bit generalization of the finding. Finally, I want to acknowledge my supervisor, Chulu, and the community of anti-voice Shisha.
So you have about the multi classify basically, right? Classify. For example, face or voice, right? So have you compared the individual classifier, the performance of individual classifier? For example, you're just using facial recognition. What's the accuracy?
Yeah, in the literature review, face, the fingerprint, and the iris, because it's all I put on in my document. So face is less in accuracy. Next is fingerprint. The iris is the highest accuracy for identification.
Yeah. So now the question is, if you do the average, as you have done, right? Maybe the highest accuracy will be dropped because say we have 3 classifiers. One classifier do the best, and let's say the third classifier do the worst. If you simply average it, it means that the performance will drop. If we simply using the first classifier. Make sense?
Yes.
So then why you do your multimodal classification? I just choose the highest one. My question is, in your experiment, have you compared your multimodal classifier with a single model classifier? That's my question. You know what I mean?
Yeah, I understand.
So have you do these studies?
Yeah, I studied you mean single model?
Yeah, single model. In your experiments, not from the literature.
One advantage in single model, multimodal, in single modal is, for instance, the system is a little bit difficult to access through your fingerprint. Then it's hard to not get to the system. But if the system has multimodal, then you can pass through your face or your eyes.
Yeah, but so if you do the multimodal, it assumes that you have 3 information available, right?
Yeah.
Facial.
Yeah.
But you say that you cannot get the face for whatever reason, you cannot do the multimodal, right? So my question is, if you have 3 data sources available, you have to compare multimodal with a single model, you know what I mean?
Yes.
But do you have some experiment in your thesis?
Yes, in the research review. single modal.
Yeah. So have you done this, or do you have PPT show that single model accuracy? Not from the literature, but from your study. Yeah, have you done this?
Yeah, I go through in the
Yeah. So can you show me the PPT?
not in the this not.
Yeah. So it's all in one page, in which page of your thesis that you have compare your performance between the multimodal and the single model. Because
No, I studied. I took on in the literature review.
yeah, so that's the problem.
Yeah.
Yeah, you should done it by yourself. Yeah, okay, that's my question.
Okay, I ask a very similar question. Do you think about the probability of success views? I mean, if you have one model, for example, the facial verified, and maybe the success rate is 90%, okay, it's very high. But if you combine three models, the finger, the facial, and voice, and we suppose that each model has a success rate of 90%. So the total success rate is 90% times 90% times 90%, maybe around 70%. So in fact, the multimodal will reduce the convenience. Is that right? So do you consider this situation?
Actually, in the literature review, three of them are not equal accuracy. Partial recognition is very less accuracy rate. So the threshold is a little bit high. Save the threshold by training the system. So in this case, we use multimodal. For instance, first you have to check to get sequential, maybe from the database size so increase, so the probability of the face recognition maybe 100% are this mark will look like 100 people or 1,000 people. Then you took these 1,000 people and check them again by their fingerprint. The fingerprints also brings this fingerprint is matches among this 10%. So even if it's not sure, the system not are sure, select 1%. Then you took that and search them through iris. Iris is so high accuracy that it takes high performance of system. So then finally you can get the individual who is the
So if for one individual, if your system will check all the models, I mean, you will sacrifice some convenience for highest security. Can I say that?
The main problem is like this. For instance, in the database, let's assume in national ID system, population are registered in the system. So someone comes to update or to, maybe to register a new ID. In this case, he has to give his demographic data, his name, like that, and also his biometrics data.
Yeah, I know that.
Then when he gives his biometrics data, the system says this man is already registered. But his data is not there because the system gets some similar, it's called, the image is changed to minutia. It's called, finally, our fingerprint image is calculated and changed to minutia. So the minutia in the system is not the new person, but it looks like, because the system answer return the result based on a certain threshold. So in this case, if you use multimodal, we can avoid such kinds of false acceptance as false rejection of.
So okay, thank you.